Swayam Prabha. Digital India. Educated India.
Welcome to the course Geology and Soil Mechanics. So, in the last couple of lectures, we solved a few problems on the shear strength of soil. So, today we will be starting the new chapter, that is earth pressure theory on the retaining wall or any kind of structure which is retaining some soil on the other side. Okay. So, this kind of structure is very common in practice. So, you know, I mean, slope stability or retaining structure or embankment or any kind of, say, any structure which is creating or which is dumping a mass of soil. So, that will basically need to understand the pressure exerted on the on any kind of plane. Okay. So, suppose you might have seen that water front structure or some retaining structure. So, on one side you have nothing actually, I mean, you have some other structure like your road or any kind of, say, built up area, but on the other side, okay, on one side you have this kind of, say, structure like road or highway or embankment or any kind of, say, civil engineering structure, and on the other side it is retaining the soil. Okay. So, this kind of structure will be experiencing some pressure exerted by the soil mass, basically which is retained by this wall. Okay. So, structures that are built to retain vertical or nearly vertical earth banks or any other material are called as retaining wall. So, that means you might have seen, I mean, this is very common in, say, hilly terrain or hilly road. If you travel by any kind of hilly hill station or something like that, you will be seeing that one side you will be having the mountain or the hill slope, and that is retained by some wall, concrete wall or masonry wall or maybe rock masonry wall, any kind of, I mean, this kind of wall, right. To know the stability of this wall or to understand the stability of this wall, you need to know the concept of earth pressure, which is a very important, okay, phenomena in soil mechanics. Suppose, I mean, you might have seen, say, suppose this kind of wall you have, okay, and on one side you have the soil. So, this is known as backfill, and another side you may have road, okay, or maybe other structure, any kind of civil engineering structure which will be coming on this side, but this side will be filled with soil. Okay. So, this soil, this filled up soil is known as backfill, and this soil is retained by this wall. So, that is why this wall is known as retaining wall, and now this slope could be vertical backfill, I mean vertical, that means horizontal surface, this surface may be horizontal or may be inclined. Okay. So, whatever may be the case, the wall is supposed to carry the pressure which is exerted by this backfill soil. Now, we need to understand how much pressure it will exert on the wall. Okay. So, there are different conditions at which you will be getting the pressure on the wall. So, what are the different conditions? First one is earth pressure at rest. So, whenever we are talking about earth pressure, basically earth pressure is nothing but the lateral pressure. Okay. And already we have seen in the previous say drawing that you have the retaining wall, and on one side you have the built up area or any other civil engineering structure, and another side you will be having the backfill. Now, this backfill, due to this vertical pressure, it will exert some horizontal pressure, and we will see, I mean, why this horizontal pressure is actually coming into the picture, I mean, how it is coming into the picture. So, some horizontal pressure will be exerted on the wall, retaining wall. This horizontal pressure is known as earth pressure, and we need to understand the earth pressure, the determination of earth pressure at different conditions. Now, for example, first one is earth pressure at rest. Now, if the wall does not move even after filling the material, that means when first what is the procedure? First we construct the wall. So, this is the wall we construct, say it could be concrete wall, it could be RCC wall, or maybe rock masonry wall, or maybe brick wall, depending on the situation you can go for different kinds of wall. Now, this wall will be constructed first, and then we fill the soil and we compact this soil to the desired strength, and that is why it is known as backfill. That means you are filling it back. Okay. So, if the wall does not move, now you are filling it, I mean you are making the backfill on the other side of the wall. Now, if the wall does not move even after filling the materials, that means even after filling the backfill material, if the wall does not move, that means whatever wall was constructed, generally what is the tendency that you fill the material, wall will try to move or try to slide from the original location to the other side, right. But if the wall does not move, that condition is known as, at that time whatever pressure is exerted by the soil, by the backfill soil on the wall will be known as earth pressure at rest condition. Okay. Now, the second condition is active pressure. If the wall moves away from the backfill, the unit pressure gradually reduces. That means, in this situation, if the wall moves in this direction due to the backfill, that means you are filling it, you are compacting it, and due to that whatever pressure is exerted on the wall. Okay. So, this is the pressure exerted on the wall, and due to that pressure, if the wall starts moving away from the backfill, then that condition is known as active condition, and at that time whatever pressure will be exerted on the wall, that will be known as active pressure. Pressure means earth pressure, as I told you that active pressure or earth pressure rest, whatever we are talking about, that is nothing but the lateral pressure. Okay. The pressure on the wall, that means horizontal pressure on the wall. Okay. Now, similarly, obviously there could be another condition where the wall moves towards the backfill. Now, that is known as passive pressure. So, in passive pressure, if the wall moves towards the backfill, the pressure gradually increases. That means, in case of active state, what happened? That wall starts moving away from the backfill. So, therefore, pressure is getting released. The pressure, I mean whatever pressure was there at rest condition, slowly or gradually it will be released or it will be decreased, okay, and to get the active state. But in case of passive state, wall is moving in this direction, that means wall is moving towards the backfill, that means you are pushing the wall towards the backfill. So, therefore, your pressure will be increasing, okay, further from the rest condition. Whatever you had the pressure at rest condition, your pressure will be further increasing at active state. Now, what kind of condition or what kind of situation will cause this kind of passive pressure? Suppose you have the retaining wall, okay, on other side you have the soil, that is your backfill. Now, this retaining wall is retaining some water. Okay, this is some waterfront structure, say for example. Now, this water pressure will try to push this wall towards the backfill, am I right? So, this pressure due to the wave or due to any kind of static hydrostatic pressure, you will be getting some static pressure on the wall, which will try to move the wall towards the backfill, and at that time your pressure, whatever pressure will be generated or exerted on the wall, like the lateral pressure, that is known as your passive pressure, right. So, these are three conditions. One is earth pressure rest condition, when there is no movement of the wall, wall is stationary. When the wall is moving away from the backfill, at that time you will be getting active condition, that at that time whatever pressure will be exerted on the wall, that will be active pressure, and when the wall will be moving towards the backfill, at that time that condition is known as passive condition, and the pressure will be the passive pressure. So, these three conditions we will be analyzing separately, and we will be trying to find out, or we will be trying to express the or determine the expressions to find out the pressures at different conditions. Okay? Now, let us go by that. Now, as I told you, in the active condition, you see this is the wall, say AB is the wall. So, this is your wall. Okay. Now, this is the center line of the wall as shown here. Now, this wall, if the wall is moving, so there are several kinds of movement. Now, this movement whatever is shown, this movement is rotation with respect to the base. This is the center line after movement. So, this is a wall. Now, it can move like this, that means rotation with respect to the base. It can move like this, rotation with respect to the top, okay, or it can slide. Simply the whole thing is moving in the horizontal direction. So, any kind of movement will give you the active state or active pressure generation. Okay. So, due to this movement, basically what will happen, soil will try to move, this backfill soil will try to move in this direction. So, this is the direction of movement of the backfill soil, right, but soil resistance will try to resist that movement. So, that is why you will say this is say failure surface you are getting, actual failure surface will be curved one, this is the failure surface, but to idealize the problem we will be solving with respect to this failure surface, that is a linear failure surface which will be making a triangular wedge, right, triangular failure block. So, this block, so ABC, this block will try to move along with the wall, and the soil pressure or soil resistance, what it will do, it will try to resist that kind of movement. Okay. That means, this is the wedge, this is the triangular wedge, it will try to move in this direction. So, therefore, this is the direction of movement, and you will be getting the resistance which will be developed at the failure surface, and this resistance is nothing but your shear resistance, right, as we discussed in the last chapter, that every resistance which will be, which you generally get from the soil. So, that resistance is generally based on the shear resistance, right. So, this resistance will be developed and slowly gradually it will mobilize, and when the complete mobilization of the shear strength is done, then the wedge will move along with the wall, right. So, this is the phenomena. So, that is why whatever pressure. So, now basic, I mean if you look at the wall, this is the wall, this is the backfill wedge which is failing, and this is the soil at rest condition, right. So, you will these are, I mean, free bodies. Now, if you try to show the resistance, so it will try to move in this direction, move towards the wall. So, it will try to move in this direction. So, the resistance will be in this direction, whereas the resistance on the soil which is under rest condition, that will be like this. Okay. Similarly, the wall, if you consider the wall is perfectly rough, that means there is no slippage between the wall and the backfill wedge, then the whole thing will be moving together. If you consider the slippage, that means the wall is not perfectly rough, it is partially rough, that means some smoothness is there. So, therefore, this wedge and the wall, I mean that at the interface you will be having some relative movement, right. So, the wall will be moving like this and wedge will be moving like this. So, there will be another resistance which will be acting on this side, right. So, this is the free body diagram, or this is the kind of mechanism, okay, which is happening during active earth pressure condition. Similarly, in case of passive, what I told, that the wall is moving towards the backfill. So, this is the wall center line. Now, this is the center line. So, that means similar way. So, you can have the rotation with respect to base, you can have the rotation with respect to top, and you can have the complete translational movement towards the backfill, and due to that you will be getting the failure surface, because failure surface means at the extreme point when the complete shear mobilization happened, the complete shear strength is mobilized, at that time you will be getting the failure, that is on the verge of failure, right. So, when you push that, and if you reach the failure condition, then basically your resistance, shear resistance will be developed along this. This is the actual failure surface which generally develops, but it can be idealized with say linear failure surface, and now this wedge will try to move in this direction, right. So, your shear resistance will be acting in this direction, right. So, that means this is the wedge, okay. You are pushing this wedge, it will try to move in the upward direction, this is the direction of movement. So, you will be getting the shear resistance which will be developed at the surface, at the interface like this, and so this is moving in this direction. So, basically you will be getting the free body diagram of this wedge like this, right. So, these are the things we are going to analyze, and we are going to obtain how we can quantify this pressure, earth pressure at rest, earth pressure at active condition, earth pressure at passive condition. Now, one more thing I would like to tell you, that in this previous figure, in the active condition, generally it has been seen that this angle, this failure surface angle or the failure surface, which will be making an angle 45 plus phi by 2, okay, 45 degree plus phi by 2 with the horizontal, and it is not arbitrary. Why it is like that, we will be coming to that point later on. It depends on your Mohr circle representation and the shear line, right. It is not arbitrary. Now, this delta, this angle is nothing but the angle of internal friction or angle of interface friction rather. So, that is the friction between wall and soil, okay. So, if delta is equal to phi, that means it is completely rough condition. If delta is 0, the wall is completely smooth condition. So, why I am calling smooth and rough? So, suppose you are talking about concrete wall which is having some rough surface. Now, that surface is touching the soil on the other side, that means on the backfill side. Now, that surface, whatever shear resistance it will provide, it will not be, it may not be same if you provide some smooth steel wall, and that interface whatever resistance or whatever interface friction you will be getting, that may not be same, right. So, the steel wall will be acting more like as a smooth wall, that means you do not have any kind of roughness at the interface, whereas the concrete wall will provide some roughness, and because of that you will be getting different values of delta, and because of that you will be getting the angle. If delta is 0, basically PA, that if the wall is smooth, then PA will be completely horizontal. If delta is not 0, then you will be having the PA which is inclined with the horizontal. Similarly, similar situation happens for passive pressure also. Now, based on the wall movement, we can have, and we can see the different conditions. So, suppose this is the wall, okay, this is the wall, and at rest condition you are getting say P naught. At rest condition, say pressure is P naught, okay, total pressure is P naught. Now, as I told you, if the wall moves away from the backfill, so this side is backfill, say this side is free. So, if the wall is moving away from the backfill, so gradually your pressure is decreasing, and at ultimate state you will be getting the active pressure, that is PA, and at that time this is the movement, delta A is the movement required to get the active pressure. So, what you are getting at rest condition, this is the pressure, and gradually you are moving the wall away from the backfill. So, gradually or slowly your shear strength is getting mobilized, and at the ultimate state, when the shear strength is completely mobilized, at that time whatever pressure you are getting, that is your active pressure PA, and to obtain this PA you need to have this much of wall movement away from the backfill. Similarly, if you start from the rest condition and if you start pushing the wall, so basically your earth pressure at passive condition is going on increasing, gradually increasing, as I told you, right. Passive pressure will be gradually increasing, and at the ultimate state you will be getting the ultimate passive pressure, and that pressure is known as Pp. Okay. And to obtain Pp, you need to have this much of displacement delta P, which is very greater than. So, delta P is very greater than delta A. Okay. That means you need to exhaust a significant amount of displacement or the movement to get the passive pressure, whereas at a very low amount of or very less amount of movement of the wall away from the backfield will cause the active state. So, now this curve, this S curve will define that how the pressure is getting built up, right. So, this is the earth pressure rest. If you gradually start moving the wall away from the backfield, so pressure will be decreasing and ultimately it will reach the active pressure. If the wall is moving towards the backfield, then the pressure will be gradually increasing and ultimately it will reach the passive pressure. I hope that you have understood. So, this is towards the backfield, this is away from the backfield. So, in this movement, in this process, basically you will be getting the active pressure, rest and passive pressure. So, from this figure it is very clear that Pa is very less than Pp, right. The active pressure is very less than passive pressure, and that P naught, say at rest condition, P naught is in between. So, Pa is less than P naught, less than Pp, right. So, as you have seen here, and now we are going to quantify this. Now, to understand this phenomena, we need to see the Mohr cycle representation. Now, this is the Mohr cycle representation. What is happening here? Now, at any situation, okay, say at rest condition, okay, this is the rest condition we are considering, and this is nothing but by sigma v. Now, what is sigma v? That is the vertical stress on any. So, if this is my wall, so at, and say this is the z direction, at any depth z, okay, I can calculate sigma v, that is the vertical stress. What is that vertical stress? Gamma into z, gamma, where gamma is the unit weight of the soil and z is the depth, right. So, sigma v if I consider, and at that time, at that location, okay, at which is z distance below the ground surface, at that location if I want to find out the earth pressure at rest condition, okay, then say at that location I am getting say P naught. This is my earth pressure rest condition. So, this surface, if I consider this surface, so this surface is free from any shear stress. So, that gamma z, that is sigma v, is nothing but the principal stress. Okay. So, that is nothing but the principal stress, and that principal stress is causing this P naught. Therefore, P naught, I mean this surface. So, if I consider a block, soil block like this. So, this is your sigma v and this is your P naught, right. So, sigma v is nothing but gamma z, that is your major principal stress, because that is the action, and due to that you are getting P naught, which is another principal stress, which is nothing but the minor principal stress. So, now if I want to show this on in the Mohr cycle representation, so it will look like this. So, circle A, this circle will be representing that condition, that earth pressure rest condition. Now, wall is gradually moving away from the backfield. Now, what will happen? Your gamma sigma v will be remaining same, that is your major principal stress will be remaining same, isn't it? The major principal stress will be remaining same, only thing is that your gradually it is moving away from the backfield. So, the lateral pressure will be decreasing. If the lateral pressure is decreasing, that means your sigma 3, that is the minor principal stress, is decreasing. So, minor principal stress is gradually decreasing, right. So, from A you are getting circle B, and at the ultimate state you are getting circle C. So, this is nothing but this circle. Okay. So, this circle will be telling you about the state of stress at active condition, and at that time this point will be giving you the minor principal stress at active condition, which is eventually PA, which is nothing but PA, right, active earth pressure. So, I hope that you have understood. So, this is your starting circle, starting mode circle A, that is earth pressure rest condition, gradually wall is moving away from the backfill. So, the sigma V is remaining same, because you are considering at a particular depth Z. So, there is no question of changing sigma V. So, only change is happening in the lateral pressure, and which is nothing but your sigma 3 and nothing but this point basically. So, this point is gradually moving in this direction, and ultimately it will be coming at this location where the Mohr cycle will be touching the Mohr Coulomb failure envelope. Okay. So, this is your active pressure circle. So, this circle, circle C, is nothing but your active pressure circle. From this circle you will be getting the information about the active pressure. Now, I am going to the passive state. So, in the passive state what we are doing? We are pushing the wall towards the backfill. Still your vertical stress sigma V will be same, that is completely unchanged, right. Gamma Z is completely unchanged, you are not changing the depth. So, gamma Z will be remaining there, only thing is that you are pushing. So, that means you are increasing the pressure. So, from P naught it will move in this direction. So, in the process you will be getting say circle D, and finally you will be getting circle E, which will be giving you the passive pressure PP, which is touching the Mohr circle Mohr Coulomb failure envelope at this point. Okay. So, this is your PP, this is your P naught, and this is your PA. Okay. So, this is the Mohr cycle representation of the active and passive pressure as well as earth pressure at rest condition. So, I will stop here today. In the next lecture we will be talking about the expression of the active and passive earth pressure coefficients. Thank you very much.